Hello, my name is Sanika Chaudhary and I will talk about Sinai Walk, which is a random walk in random environment. Random walk models are widely used to describe various physical and biological phenomena, such as Brownian motion, ideal chains, and genetic drifts. One of the most famous random walk models is the Sinai random walk model, named after Yakov Sinai, a Russian mathematician who introduced this model in the 1980s. The Sinai Walk is a one-dimensional random walk model that is defined on a lattice where the particles move from one side to the other with some probability. If the particle is at site n at time t, then at time t plus 1, it will either be at site n plus 1 with probability pn or at site n minus 1 with probability qn, which is 1 minus p. In a simple random walk, the particle moves randomly between adjacent lattice points with equal probability. The distance moved by the particle at time t is then just the sum of displacements of the particle at each time step. In Sinai's walk, the particle's movement is governed by more complex probabilities, resulting in non-trivial motion. On a network, diffusion can be modeled using a random walk, where particles move from one node to another along the edges of the network. Sinai's random walk provides a way to analyze the behavior of random walks in complex systems, where the edges have different weights. Effectively, the probability Pn at site n depends on the position n of the random walker. In Sinai's model, the probability Pn that the random walker jumps to the right at position n is an independent, identically distributed random variable in 0, 1, and the net bias is 0, or the average of log of Pn by 1 minus Pn is equal to 0. The graph for Sinai's walk is more confined than for an ordinary random walk. When log of Pn by 1 minus Pn has finite and positive variance as well, then the distance covered by the particle at step n is of the order of log square of n, which is much less than the usual root of n for simple random walk. For a particle in a one-dimensional random walk system, the time evolution of the probability for the particle to be on site x at time t plus 1 is governed by the equation given over here. One of the key properties of Sinai's random walk is the drift velocity, which is the average speed at which the particles move over time. It is given over here. Another fundamental parameter which characterizes the behavior of the random walk model is the diffusion coefficient, which is the measurement of rate of dispersion of particles. The diffusion coefficient in Sinai's walk is related to the mean square displacement of the particles over time. It depends on the size of the system, number of particles, and the time interval. Here, I will discuss two different cases, the pure asymmetric case and the random symmetric case. So what is the pure asymmetric case? Here, for all steps n, the probability Pn is equal to some constant P right, and the probability Qn is equal to P left. Or effectively, the probability to step from n to n plus 1 is the same for all n, and the probability to step from n back to n minus 1 is also the same. In this case, the drift velocity and the diffusion coefficient is given over here. Similarly, in the random symmetric case, for step n, the probability Pn is equal to Q of n plus 1, which means that the probability to step from n to n plus 1 is the same as the probability to step back from n plus 1 to n. In this case, the drift velocity becomes 0 and the diffusion coefficient is given here, where n is the total vertices in the lattice and W of n plus 1 comma n is the probability to jump from n plus 1 to n. Sinai's walk has several applications in various fields, including physics, chemistry, biology, and computer science. For example, it can be used to estimate the diffusion coefficient of particles, which is used for drug analysis, protein analysis, etc. It can also be used to study networks such as social networks, transportation networks, communication networks, and find the clustering coefficient and degree of distribution, etc. It is also used to generate random sequences to test the efficiency of algorithms in computer science. It can be used to simulate different types of random walks, like biased walks, etc. Thank you.